Hello guys, this is VI characteristics of DIAC. So this particular experiment that we have set up, this is the power supply, and that's the springboard. So the one which you're seeing right here, this blue color tiny thing is the DIAC. This particular thing is DIAC. Now it's bidirectional component. Now this is the voltmeter that we have to connect. Either you can give it to the digital multimeter, which is right here, or you can give it to any other kit which has this particular voltmeter and ammeter. It can be MOSFET IGBT kit or SCR or any other kit which has the same display. And we have the ammeter. We made use of the kit itself, or according to your convenience you can use DMM. Again, the load resistance is 470 ohms, and then the supply if you are making use of the kit, it gives only 30 volts. This particular thing gives only 30 volts, and even in this kit, this part gives 30 volts and that gives 30 volts. So if you put it in series, you can get 60 volts if you are varying from 0 to 60. So to avoid confusion, usually everybody they just there's a setting here. If it's upright, the both switches, it's independent. This works independently and this works independently. Suppose this is turned on and this is turned off, this works in series. There's an internal connection which makes the two supplies as series, so that you can get 60 volts.
You can't get odd numbers.
Yeah, you can't vary to odd numbers. You can get only even number displays. And then when you press both of them, this works in parallel, so you won't be using it. So to avoid confusion, the best thing that I suggest you is, you have two batteries, right? This is an everyday battery, and this is, you have two Duracell batteries. If you want to connect them in series, people get confused. These are two batteries, so now these are in series. So if you have to connect this way, you have to short this and this, and then now these batteries are in series. The same way, the negative to positive, and then positive negative. So this is 30 volts, this is 30 volts. Together you get 60 volts. So these two are shorted. And then the positive is given to this, the negative is given to that. Now if you want 60 volts, you need to give 30 here and then 30 there. Suppose you want 8 volts, you need to give 4 volts here and then 4 volts there.
Or you can give 8 over here.
Anyways, it need not be symmetric, but that is more preferable. Suppose, I'll show it to you. Now it's some 4 volt and then 4 here.
4.5 somewhere.
It's somewhere 4.5 plus 4, and then you'll get 9 volts.
It's not mathematically correct.
Not mathematically correct, since it is practical. That's how it works. Now in this setting, you need to keep in any power supply, the current knobs should be at maximum. These shouldn't be pressed, and then this should be minimum. Okay, now the experiment. All you have to do is you need to get this graph. So consider this particular first quadrant where you need to vary the voltage. Suppose you vary till the voltage will be varied from 0 to certain value, and then when it goes to certain value, suddenly the voltage drops and then current shoots up. So yeah,
There's no change in current.
and then it will be constant, the current. So you need to look for those values. So vary the power supply knobs. Yeah, look at that and look at this. 19 volts, 22 volts, 28, and then 30, and then current started increasing, and that went down.
Sure, went down.
It went till 28 something, right? And then
I'll show you.
see, it's 20, 22,
18.
yeah.
There is no current.
19, 21, 23, 28.
And we'll start from there.
Yeah. Now increase this. That is at maximum. Now look, that's decreasing.
Current
Now
is
this is increasing. So note down the corresponding voltage value and the current value. You need to note down that voltage and this current in the tabular column, and then you just plot the graph for the first quadrant.
It is for this one, negative.
And for the second quadrant, what do you have to do?
Actually, this is negative.
Actually, it's showing negative sign in the sense we are getting the third quadrant graph. If you want the first quadrant, then you'll just have to interchange the IGBT. Just take it out, turn it, and place it. DIAC. Sorry. Just take it out, place it. That's it. Either you can interchange the terminals of DIAC, or you can just change the terminals of the supply. Just plug this out and interchange this terminal and this terminal.
That is only better choice.
That's the better choice. To avoid confusion, don't meddle with this. Just follow whatever's there here. If you are not confused with this, you may proceed with that method itself. Yep, that's it.
That's it.
Yeah, thank you.